Okay, sir.
Okay. No, beta, no. You mean to say angle P is getting bisected? No, 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 no. In no, no. वैसे नहीं होगा बेटा. Just give me a minute. Let me put it on. No. In a PAB triangle, the midpoint of the great circle track, midpoint between A and B, will not be the middle longitude point. Okay, it will not be the middle longitude point. What you are saying is only possible in one condition. That is possible only if the initial and final positions are exactly at the same latitude. They are on the same parallel of latitude. In that case, yes, the triangle will be perfectly symmetrical. And in that case, the midpoint will also be the middle D long point. Only in that case. Okay, not otherwise. Okay. Or beta, any more doubts?
Sir, in the question number 10, this both the latitude is on the meridian, sir. And from A, they have given one distance to C. And from B, they have given the initial course only. How to go about this problem, sir?
Did you go through the solution, beta?
Yeah, yes, sir. There they have given the side is 90 degrees. I don't know how to find whether the side is 90 degrees or not. This diagram I have drawn.
Okay. What is the distance between the initial position and the destination port, the third point?
Sir, is 5,400 miles. Something.
Okay. Now, if you convert 5,400 miles into degrees, how many degrees will it be, beta? Just punch in the numbers in the calculator.
Okay. Copy.
Okay.
So, but that distance is from A to C, sir. But the initial course is given from another latitude.
That's right.
That is from B to C. So there are two
That's
points going to.
That's
So
right,
which
beta.
triangle do we start first?
Okay. There is a option you can start. Just have a look at the solution now. Both the triangles, Papa Alpha X-ray and Papa Alpha Bravo X-ray, both of them are having a special side, that is 90-degree side. So you can start from any one of the two. There are two possibilities how it can be solved. Now just look at the solution. You should be able to get the direction now. If still not clear, tell me again.
This AC distance is 5,400 miles, sir. Then BC will also be the same distance.
No. BC will not be same, but triangle ABC has one side AC which is 90 degrees.
Okay, then okay, copy, sir.
Okay, then you can apply the Napier's rule in any one of the two triangles.
Okay, sir. Okay, thank you.
Okay. ओके बेटा, ग्रेट. अब बेटा आज मुझे आपको ना 2-3 चीज़ें करानी है. 2-3 important things I will be covering up with you before we proceed ahead. Mercator sailing you have told. Mercator sailing I will proceed, but after covering these topics. Now these are some typical questions in great circle sailing and composite sailing. Okay, what are these typical questions? Now in some of the great circle sailing questions, they may give you 3 angles. Last lecture also somebody told that there is a question in which 3 angles are given. So I will tell you today that how these kind of questions can be approached, how they are to be solved, where 3 angles are given. Because cosine formula will not apply, Napier's rule will not apply if there is nothing equal to 90 degrees. So what is to be done there? For that, we have to understand the concept of polar triangles. So I will show you that concept. And along with that concept, I will tell you one more complicated, tricky question. It has not come in the exams yet, but if anytime somebody tries to put a bouncer, so you will have an idea how this is to be approached. तो पहले मैं ये आपको बताऊंगा. Then I will show you a typical question in composite sailing. What is that typical question? When the limiting latitude becomes equal to the latitude of one of the ports, then the composite sailing question becomes little tricky. So ये मैं आपको दिखाऊंगा. One by one we will see these two topics, and after this then I will take you to other sailings, plain sailing and Mercator sailing, and I'll clarify how those sailings are done. Right, beta? Ready?
Yes.
Ready to go ahead?
Yes.
Okay. So today's topics are little tricky, and you need to pay attention. So have a cup of tea, coffee ready with you, and pay your attention. These are important and complicated topics. So let's go into them one by one. So beta, first I am taking you to the concept of polar triangles. Let's go. Let's now go into the concept of polar triangle. First of all, we will understand what is the need or use of this polar triangle concept. Now we are aware that the cosine formula can be used in two situations, in two conditions. One, when all the three sides of a spherical triangle are known to us. And second, when any two sides of a spherical triangle and the included angle is known to us. Cosine formula can be used only in these two scenarios. Now, cosine formula cannot be used if we know three angles of a spherical triangle. Let me show that in a diagram to you. We have this spherical triangle PAB, Papa Alpha Bravo. And you can see that these green tick marks indicate that we know all the three angles of this spherical triangle. If all the three angles are known, we cannot solve this triangle, or we cannot find the remaining part of this triangle using the cosine formula. That is the limitation of the cosine formula. Also, if we have a scenario in which we know any two angles and the included side of a spherical triangle, like in the bottom diagram, you see we know angle A, angle alpha, angle Bravo, and we know side alpha Bravo indicated by the green tick marks. Now in this situation also, cosine formula cannot be used. Now in all these scenarios, the question can be solved by using the polar triangle concept. So these are the situations where the polar triangle concept comes to our help. Clear up to here, Peter? Great, very good.
Yes, sir.
Let us now understand what is a polar triangle and what are its properties, so that we can use this information to solve these type of questions. Now every great circle has two poles. The pole of a great circle is equidistant from all the points or all the positions on that great circle. And that pole is also 90 degrees away from all the positions on that particular great circles. We can take the example of the equator on the Earth's surface. Equator is a great circle, and the North Pole is the pole of the equatorial great circles. We are aware that this North Pole is equidistant from any point or any position on the equator, and also this pole is 90 degrees away from any position or any point on the equator. So the geographic North Pole is the pole of the equatorial great circle. Now when we draw a spherical triangle, we know that each side of a spherical triangle is part of a great circle. Now if we draw the poles of each of the three sides of a spherical triangle and we join those three poles together with each other by great circle arcs, a new spherical triangle will be formed. This new spherical triangle, which is formed by joining the poles of the great circles of a spherical triangle, is known as the polar triangle of that spherical triangle. Now let me explain this to you using a diagram. We take a spherical triangle. You can see the spherical triangle ABC Alpha Bravo Charlie coming up on the screen now. Now all three sides of this spherical triangle are arcs of great circles. So let's first take the example of side BC, the red color side, Bravo to Charlie. This Bravo to Charlie is part of a big great circle. Now let us assume that this great circle corresponding to side Bravo Charlie has its pole at this particular point. You can see this point A dash, alpha dash coming up in the diagram. This point A dash or alpha dash is the pole of the great circle track Bravo to Charlie. Now likewise, the second side of this spherical triangle, let's take the example of side Alpha to Charlie, the blue color side. This side is also part of a great circle. Let's assume that the pole of this great circle is at this particular point Bravo dash. You can see point Bravo dash coming up in the diagram now. This point Bravo dash is the pole of the great circle track Alpha to Charlie. And now let's take the example of the third side. The third side of the spherical triangle, green color side, is Alpha Bravo. Let's assume that the pole of this great circle track Alpha Bravo is at this particular point represented by C dash, Charlie dash. So Charlie dash is the pole of the great circle track from Alpha to Bravo. Now we have the poles of all the three sides of our spherical triangle. Let's join these poles using great circle arcs. So let's join Alpha to Bravo using a great circle track. You can see the great circle track now, which is joining Alpha dash to Bravo dash. Let's now join Bravo dash to Charlie dash using another great circle. You can see this red color great circle joining Bravo dash to Charlie dash. And let's now join Alpha dash to Charlie dash using another great circle. This blue color great circle is joining Alpha dash to Charlie dash. This bigger triangle which we see in the diagram now, Alpha dash, Bravo dash, Charlie dash, which is made by joining all the three poles using great circle arcs, is known as the polar triangle. The original spherical triangle which we had, that is the smaller triangle Alpha Bravo Charlie triangle, this is called as the primitive triangle of the polar triangle. So the smaller triangle is known as the primitive triangle and the bigger triangle is known as its polar triangle. So the same thing what we discussed is mentioned here. Alpha Bravo Charlie is the primitive spherical triangle. Alpha dash is the pole of side BC, side Bravo Charlie. Bravo dash is the pole of side AC, Alpha Charlie. And Charlie dash is the pole of side AB, alpha Bravo of the primitive triangle. And A dash, B dash, C dash is the polar triangle of the spherical triangle ABC. Now, once we understand the concept of polar triangle, we can go into its properties, which will help us to solve these kind of questions. Any doubts up to here, beta?
Yes, sir. One doubt, sir.
Go ahead.
This angle at A and the angle at A dash, will they be same, sir?
No, beta, they will not be same. They will be different.
Okay, sir.
Okay, beta. Great. Very good. Now, a very important property of the polar triangle is known as the supplemental theorem. Let's try to understand what this supplemental theorem is. This theorem says that the sides of the polar triangle are the supplements of the corresponding angles of its primitive triangle. Two values are known to be supplements of each other if they add up and total to 180. So let's try to understand this property using this diagram. Now, the sides of the polar triangle are alpha dash, Bravo dash, Charlie dash, and alpha dash to Charlie dash. Now, if we pick up a side of the polar triangle, let us for our first example pick up the side, red color side, Bravo dash to Charlie dash, and we pick up a corresponding angle of the primitive triangle. Now, in the primitive triangle, we have three angles, alpha, Bravo, and Charlie. The angle corresponding to side Bravo dash Charlie dash is angle alpha. You can also understand it easily by considering angle alpha is opposite to side Bravo dash Charlie dash. The supplemental theorem says that the side of the polar triangle Bravo dash Charlie dash and the supplement and the corresponding angle of the primitive triangle, that is angle alpha, are supplements, means they add up to 180 degrees. That is exactly what is mentioned here. Bravo dash Charlie dash plus angle alpha is equal to 180 degrees. So let us correlate it with the text of the theorem. Side of the polar triangle, the side of the polar triangle taken is Bravo dash Charlie dash, is the supplement of the corresponding angle of the primitive triangle. The corresponding angle or the opposite angle of the primitive triangle is angle alpha. Both of them add up to 180 degrees. So this basically tells us that if we know angle A of the primitive triangle, 180 minus angle A will give us the side Bravo dash Charlie dash of the polar triangle. So you can see this red color angle appearing in the diagram now. This red color angle alpha of the primitive triangle is the corresponding angle of side Bravo dash Charlie dash of the polar triangle. Now likewise, if you pick up the blue color side of the polar triangle, that is alpha dash to Charlie dash, the angle corresponding to it in the primitive triangle is angle Bravo. You can see angle Bravo is opposite to side alpha dash Charlie dash. It is represented in blue color, matching with the side A dash C dash of the polar triangle. So side A dash C dash of the polar triangle plus the corresponding angle of the primitive triangle, which is angle Bravo, add up to total 180 degrees. So if we know angle Bravo of the primitive triangle, 180 minus angle Bravo will give us alpha dash Charlie dash, or the corresponding side of the polar triangle. Now taking it to the third side of the polar triangle now, the third side, green side, which is alpha dash Bravo dash, the corresponding angle to this side in the primitive triangle is angle Charlie, represented by the green color angle. The sum of these two, alpha dash Charlie, alpha dash Bravo dash plus angle Charlie of the primitive triangle is also 180 degrees. Now moving further, the angles of the polar triangle are the supplements of the corresponding sides of its primitive triangle. Now let us have a look at the angles of the polar triangle. We have three angles: angle alpha dash, angle Bravo dash, and angle Charlie dash. The supplemental theorem says that all these three angles are supplements of the corresponding sides of the primitive triangle. Now let's follow this property one by one. Let's pick up angle alpha dash first. We have marked this angle in red color. Angle alpha dash and its corresponding side, mean the side opposite to it in the primitive triangle, is side Bravo to Charlie. Bravo to Charlie is the red color side. So angle alpha dash plus Bravo Charlie side of the primitive triangle will add up to 180. You can see that noted down here. Alpha dash plus side Bravo to Charlie of the primitive triangle is equal to 180. So you can match it with the working now. Angle of the polar triangle, which is angle alpha dash, and the corresponding side of its primitive triangle. Corresponding side of the primitive triangle is Bravo to Charlie. They add up to 180, or both these parts are supplements of each other. We can follow this with the second angle. Let's take example of angle Bravo dash. Angle Bravo dash and the corresponding side of the primitive triangle, which is alpha to Charlie, will also add up to 180 degrees. Let's now understand this with the third angle. Third angle of the polar triangle is angle Charlie dash. Angle Charlie dash plus its corresponding side of the primitive triangle, which is alpha to Bravo, they will add up to 180. This is the supplemental theorem. Now, if we know the sides of the primitive triangle, then 180 minus the side will give us the corresponding angle of the polar triangle. So if any one of the two items is known, the other item can be easily calculated using the supplemental theorem. Any doubts up to here, beta? Very good, beta. Great. Let's now apply this supplemental theorem in scenarios where cosine formula cannot be used. Let's pick up the first scenario that we know the three angles of the primitive triangle. You can see the known parts of the primitive triangle marked by green tick marks. We know all the three angles of the primitive triangle: angle A, angle B, angle C. All three are known. Now we want to find the remaining parts of the primitive triangle, that is the three sides. Cosine formula cannot be used in this condition. So let's now see how supplemental theorem helps us here. Now we are aware that angle A of the primitive triangle plus side Bravo dash Charlie dash of the polar triangle, these are corresponding parts, they add up to 180 degrees. So if we know angle A of the primitive triangle, 180 minus angle A gives us side Bravo dash Charlie dash of the polar triangle. So we can easily find out side Bravo dash Charlie dash. Likewise, angle B of the primitive triangle plus side alpha dash Charlie dash of the polar triangle add up to 180. So 180 minus angle Bravo gives us side alpha dash Charlie dash of the polar triangle. You can see this green tick mark coming here. And likewise, angle C of the primitive triangle plus side alpha dash Bravo dash of the polar triangle also add up to 180. It's mentioned here. So 180 minus C will give us side A dash B dash of the polar triangle. So you now see we have all the three sides of the polar triangle available to us, and we can now apply the cosine formula to the polar triangle. And by applying the cosine formula, we can find all the three angles of the polar triangle: angle A dash, angle B dash, and angle C dash can be easily obtained using the cosine formula. And once we have these three angles, 180 minus these three angles will give us the corresponding parts of the primitive triangle. So all the sides, 180 minus angle A dash will give us side BC, Bravo Charlie. 180 minus B dash will give us side AC, Alpha Charlie. And 180 minus angle C dash of the polar triangle will give us side Alpha Bravo of the primitive triangle. So you see, using this polar triangle concept, we can easily obtain the remaining part of the primitive triangle. Any doubts, beta?
So well, just one doubt, sir. Not a doubt. Just want to clear on something. As
Go
you said,
ahead.
after finding A dash B dash and B dash C dash and A dash C dash, so we got three sides of the triangle, spherical triangle, and after that we can apply a cosine formula, right, sir, to find out A dash B dash and C dash.
That's right.
Okay, copy that, sir. Thank you.
Right. You apply the cosine formula, get the three angles of the polar triangle. 180 minus those gives you the sides of the primitive triangle. Okay, beta. Great. Very good. So that was the concept of polar triangle. Let's move ahead. Now let's see a second scenario. Let's assume that we have two angles, angle Bravo and angle Charlie, known to us for the primitive triangle, and we have the included side, side Bravo Charlie. Now again you see cosine formula cannot be applied directly to the primitive triangle. Cosine formula is applicable only if we have all the three sides or we have two sides and a included angle. So cosine formula not applied. So what we can do now is use this supplemental theorem to find the parts of the polar triangle. So let's do that. Now we are aware that side Bravo Charlie and angle A dash of the polar triangle are supplements. 180 minus side BC gives us angle A dash of the polar triangle. Likewise, 180 minus angle Charlie gives us the side A dash B dash of the polar triangle, and 180 minus angle Bravo of the primitive triangle gives us side Alpha dash Charlie dash of the polar triangle. Now if you pay your attention to the polar triangle, we have two sides, Alpha dash Bravo dash and Alpha dash Charlie dash. These two sides are now available to us, and we have their included angle also, angle Alpha dash, available to us. So two sides and a included angle available to us, we can apply the cosine formula in the polar triangle and find the remaining parts. First we can find the side Bravo dash Charlie dash of the polar triangle, and later on if we want we can find angle Bravo and angle Charlie of the polar triangle, angle Bravo dash and angle Charlie dash of the polar triangle. Once these three parts are known, 180 minus these three parts will give us the corresponding parts of the primitive triangle. 180 minus Bravo dash Charlie dash side will give us angle A of the primitive triangle. 180 minus angle B dash will give us side AC Alpha Charlie of the primitive triangle. 180 minus angle C dash will give us side Alpha Bravo of the primitive triangle. So the remaining parts can be easily obtained. Any doubts in this, beta?
This type of questions then become a very lengthy question, no, sir, to solve.
Yeah, not very lengthy, beta. You see, it is only 180 minus a particular part, it is done in the beginning and it is done in the end. These two steps are added. Otherwise, it is like a simple application of the cosine formula. So two steps are added. Yes, it will be lengthier than a normal question.
Okay, sir.
Okay, all right, beta. Great. Now, beta, before I proceed ahead, tell me one thing. Now, there is one tricky concept in great circle sailing which has not come in the exams. अभी तक वो आया नहीं है exams में. So I just want to check with you. Shall I cover that with you? I don't want to overburden you. So you can tell me, shall I cover that with you if it is comfortable? And if it is overwhelming, then we can leave that also. It has never come in the papers till now.
Yes,
So how would you
Bata
like to go?
Bata sir.
That's better to just go through over it once.
Very good. So don't take load, okay? Just understand the method. If you see any question, अभी तक नहीं आया है, but if somebody puts a bouncer to you in this kind of format, then you will be able to solve it, okay? तो मैं आपको बता रहा हूँ, but don't overburden your mind with it. Take it very lightly, comfortably, have that with you as a reserve weapon, okay? Okay, let's go.
Sir, polar triangle का भी बहुत rarely आता है ना?
Yeah, it comes rarely, beta. In fact, it had not come for last about 10 years or so. But a couple of papers back, they had given the polar triangle question. So that's why it can be repeated anytime now.
Okay, sir.
Sir, you have any
No.
worked example for this type of problems, polar triangle?
Polar triangle?
Yes, sir.
Okay, if you want, I'll share one with you.
Yes, sir. Yes, sir.
I'll share, beta.
Okay, sir.
Just remind me if I lose track, I'll share.
Okay, sir.
Okay, all right. So let's do the typical case. Let's go. Now let me show you another tricky and complicated question involving the solution of a spherical triangle. Till now we have been able to solve the spherical triangle either by using the cosine formula or Napier's rule or by using the polar triangle concept. But there are few more possibilities in which a question can be framed. What is to be done in those cases? Now these questions can look very tricky and complicated, or these are typical type of questions. So let's understand how they can be solved. Let's take the first scenario that we are given any two sides of a spherical triangle and we are given one excluded angle. Let me show that to you in the diagram. Let's assume that we are given side alpha bravo AB, the green color side, and we are given the side alpha charlie, blue color side. You can see green tick marks coming here. These parts are given to us. And we are given angle B, angle bravo of this triangle, again shown by a green tick mark. Now we cannot use the cosine formula here. And also we cannot use the polar triangle concept here. Both of them are not going to work out. So what is to be done in these scenarios? Now for these type of questions, we need to drop a perpendicular from one vertex to the opposite side. Now when we drop a perpendicular, there are three vertices in the triangle. We have vertex A, vertex B, vertex C, Charlie. Now which vertex should we choose or pick up to drop a perpendicular? So for this, remember that the perpendicular to be considered for our solution should be the one that does not divide any of the sides or angles whose value is given to us. Like say for example, if I pick up vertex bravo and I drop a perpendicular from vertex Bravo to side Alpha Charlie AC side. Now this perpendicular is going to divide angle B. Angle B is given to us, so we are not going to use this option. This is going to divide side Alpha Charlie also, which is again given to us, so we will not use that option. Another option possible to us is vertex Charlie. If I drop a perpendicular from Charlie to the opposite side, that is Alpha Bravo, again you see the side Alpha Bravo is given to us. So this perpendicular is going to divide the given side Alpha Bravo. So this is also not to be considered. Now if you come to the third vertex, that is vertex A, if I drop a perpendicular from vertex A to the opposite side, which is BC, Bravo Charlie, now you see angle A is not given to us, its value is unknown, and side BC is also not given to us, its value is unknown. So this is the perpendicular to be considered for our solution. So I will repeat once again. The perpendicular to be considered for solving the spherical triangle should be the one that does not divide any of the sides or angle whose value is given. So it should be joining a vertex and a side whose values are unknown. So let's drop a perpendicular now. So you can see we have a perpendicular dropped from vertex A to side BC. Since it's a perpendicular, angle made at the joining point of this perpendicular to side BC, let's call that as vector. This is basically also the vertex of great circle track Bravo to Charlie. So this angle vector or alpha vector Bravo is a right angle. Now once you drop this perpendicular, you see there are two triangles which are formed now, Alpha Bravo vector and Alpha Charlie vector. Now if you look carefully, triangle Alpha Bravo vector is a special spherical triangle because one of the angles is a right angle, and we know two parts of this triangle. We know side Alpha Bravo and we know angle Bravo. Using these two parts, we can find out the remaining parts. We can find out angle A, that is Bravo alpha vector angle. We can find side alpha vector, and we can also find side Bravo vector. So once these three parts are solved, we can now go to another triangle, Alpha Charlie vector. Alpha vector has been found out already. Using alpha vector and Alpha Charlie, which is also known, we can find the remaining parts. We can find vector Charlie and we can find angle A. So all the unknown parts in this triangle can be obtained by using this technique. So is that clear, beta?
Sir, जो angle में ये cut कर रहा है vector, is that always the vertex or
that will always be the vertex, beta, because we have dropped a perpendicular. So angle vector will be 90 degrees and it will always be the vertex.
Even if we are going from initial position is north and final position is south?
Yeah, it will always be the vertex, beta. It will always be the vertex.
So even if the vertex is forming outside the great triangle?
Yes, even if it is outside, you will come to know when you calculate side Bravo vector, okay, when you will calculate side Bravo vector, you will come to know that the magnitude of Bravo vector is such that it has gone outside the triangle. Okay, you don't have to bother about it. You start it in this particular way only and solve using Napier's. Once you get the values of all these items, it will immediately tell you whether the vertex was inside or outside.
Sir, just one doubt, sir. You said we can't use that polar triangle in this.
Right, beta?
Yes, sir. Just one clarification. Why like that, sir?
Okay, beta. If you use the polar triangle in this, beta, the polar triangle will give you two angles and one side, and that side will not be the included side. So you will have two angles and one side of the polar triangle, Again, cosine formula cannot be used in that situation.
Okay, sir.
Okay. Okay, beta. All right. So this was one case. Now there is one more type of question which can be framed similar to this, but that's case number 2. So let's see
So
that
these are
case
the
number.
cases that you're saying that have not come in the exams.
Yes, that's right, beta.
Okay, sir.
Okay. So let's see case number 2 also. Let's now see another similar kind of scenario, and the same technique can be used in that scenario also. Now in this case, we have two angles of a spherical triangle and one excluded side. In the previous example, we had two sides and one excluded angle. Here, we have two angles and one excluded side. Let's show them in the diagram. You can see these green tick marks indicate that we know angle Bravo of this triangle and angle Charlie of this triangle, and we are also aware of what is side alpha Bravo, all indicated by green tick marks. Now we cannot use cosine formula here. It does not fulfill the criteria for cosine formula. And also we cannot use the polar triangle concept. Even that will also not be able to solve this. So again, we follow the same technique. We drop a perpendicular from one of the vertex to the opposite side. Now, which vertex shall we pick up? There are three vertices. The vertex or the perpendicular to be considered should be the one that does not divide any of the sides or angle whose value is given. So if I pick up angle Bravo as my vertex and I drop a perpendicular, angle Bravo is given to me. So this should not be picked up. If I pick up angle Charlie, again the perpendicular is going to divide angle Charlie. So this also should not be picked up. And if I pick up angle alpha, now angle alpha is unknown, and I drop a perpendicular to side Bravo Charlie is also unknown. So this perpendicular should be considered, where the vertex as well as the side which this perpendicular is joining, both of them the value is unknown. So let's drop a perpendicular. You can see the perpendicular now coming up. Let's mark the perpendicular point as V. This is the vertex of the great circle track Bravo to Charlie. Now exactly in the same way as we solved the last example, you see Alpha Bravo Victor, special spherical triangle having a right angle. Beta, mute your mics.
Praveen.
Okay, I'm muted. Two parts are known, Alpha Bravo and angle Bravo. We can find out all the remaining parts. And after this, we can go to triangle Alpha Charlie Victor. And using Alpha Victor and angle Charlie, we can find all the remaining parts of Alpha Charlie Victor triangle also. So using this technique, the same technique, both these complicated and tricky questions, typical cases can be easily solved.
Sir, I want to ask some query regarding in this diagram, sir.
Go ahead, beta.
Sir, you said we should select any angle, sir, like you select angle 1, sir. So how we'll know this angle should be selected for dropping the perpendicular? Can you give explanation or can you repeat this part only, sir? Because here
Okay.
third point is written perpendicular to be considered should be one that doesn't divide any
I'll
of
tell
the
you.
side
I'll
or
tell
angle.
you. I'll
Yes,
tell you.
please.
Okay. Now, beta, when you pick up a angle to drop the perpendicular, angle A, angle B, or angle C, one of the vertex of the triangle you are picking up, which one should we pick up? तो आपने ये ध्यान रखना है, you should pick up a angle which is unknown. Now you see angle B is known to us. We cannot pick this.
Okay, sir. I got now.
Angle C
Whose
known
value
to
is
us.
unknown? Yes, sir.
Yes,
Hmm.
we cannot pick angle C also. Angle A is unknown, so we will pick up angle A. Also, the perpendicular is dropping on side Bravo Charlie, and Bravo Charlie is also unknown. So this is the perfect perpendicular drop.
Okay, sir. Thank you very much, sir.
Okay, beta. Great.
सर इसका क्वेश्चन अगर आना होगा तो हाउ विल इट बी सर, मतलब कुछ एनी एग्जांपल इज देयर फॉर दैट?
Okay, I will not give it to you right now. Okay. Later on, if you want, I will give you. For now, concentrate on the ones which are coming in the exams, beta. Later on, if you tell me, I will provide you with a question having this funda also. Not now.
And one more
Okay,
thing,
sir.
sir. And we are dropping it, so we'll have to put a comment in saying that we are just taking the vertex or something.
No, you
If
just
we are,
write there, we are dropping a perpendicular from A to side BC. That's it.
that's it. Okay, sir.
That's it. Okay, beta. Great. So, shall I close this out?
Yes, sir.
Very good, beta. Great. So, I'm closing this down now. We are completed with the great circle sailing. Okay. Now, beta, the IT department tells me that some of you may be connected with two devices. So please connect with one. Huh? Okay. Okay. All right. Now, beta, I'm going to take you to a tricky question in composite sailing. Okay. So I will show you what is that complicated question and then how it is to be attempted. So this is what we are going to see. So let's go. Let me set up the presentation. Let us now try to understand a typical problem which can be asked to us in composite sailing questions. Now, if you look at a composite sailing question and you observe that the limiting latitude matches with the latitude of one of the ports, either the initial port or the final port or final position. How to approach these type of questions? Let us try to understand it by making a diagram. You can see the initial position of the ship represented as A. You can also see the final position of the ship now represented by B, Bravo. Let's mark the limiting latitude. In this question, the limiting latitude which they have given us matches with the latitude of port B. So you can see this red color dotted line showing the limiting latitude, and it exactly matches with the latitude of our final position, Bravo. Let us mark the pole. Let us assume that both these positions are in the northern hemisphere, and we can see the North Pole coming up here. Let us now mark the meridian of our initial position A. You see the Papa Alpha meridian of position A coming up. Let us mark the meridian of the destination position B. you can see Papa Bravo as the meridian of the destination port Bravo. Now in these questions, we start on a great circle track which passes from our initial position A, and it has its vertex on the limiting latitude. So you can see this green color track coming up. This should be the first track of our composite sailing. So this is the first part of our composite track, the GC track from Alpha to this particular point here. Now this point on the limiting latitude is where the vertex of this great circle track is, and let us mark this as Victor 1. Now from Victor 1, we start to proceed on the parallel track, and when we are moving on the parallel track, we will reach up to our destination position Bravo. There will be no third leg of our composite track here, because when we are moving on the limiting latitude, position B lies on the same latitude, and moving on the limiting latitude following a parallel track, a rhumbline track, we are going to reach to our destination. So we would not require or need to make a third triangle, making a great circle track from limiting latitude to the destination position. That third triangle is not required here. Only two triangles will be made. Let us now mark the meridian of the vertex. We can see Papa Victor 1, the meridian of the vertex coming up. Now we are aware that angle V1, angle Victor 1 is going to be a right angle. At the vertex, the great circle track runs east-west. The meridian of the vertex runs north-south. The angle between them is 90 degrees. Now, if you look carefully, we have two triangles in the diagram. We have Papa Alpha Victor 1 and we have Papa Bravo Victor 1. Now, out of these two triangles, if you look carefully, the triangle Papa Alpha Victor 1 is a spherical triangle. All three sides of this triangle are parts of great circles. On the other hand, the triangle Papa Bravo Victor 1 is not a spherical triangle because the side Victor 1 Bravo is not part of a great circle. It is a rhumbline track which is part of a small circle. Now, once we identify the spherical triangle, the first step in these type of questions is that we solve this spherical triangle. So we will be solving the spherical triangle Papa Alpha Victor 1. Now Papa Alpha Victor 1 is a special spherical triangle. We have a right angle at Victor 1. Napier rule says that if we know any two parts of the special spherical triangle, we can apply the Napier's rule and find everything else. The two known parts of this triangle are number 1, Papa Alpha, which is the colat of our initial position. Initial position is provided to us. And the second known part which we have is Papa Victor 1. This is the colat of the vertex or the colat of the limiting latitude. Limiting latitude is also provided in these questions. So with these two parts known to us, Papa Alpha and Papa Victor 1, we enter into the Napier's rule and we first calculate angle P of this triangle, that is angle Alpha Papa Victor 1. This angle is the D long between Alpha and Victor 1. If we apply this D long to the longitude of our initial position, we will get the longitude of Victor 1 or the longitude of the vertex. Now, once we have the longitude of the vertex known, we can again apply the Napier's rule. And now we can find out Alpha Victor 1. This gives us the distance along the great circle track Alpha Victor 1. And we again apply the Napier's rule now to find the initial course using angle A. We find out angle A, that is Papa Alpha Victor 1. And this angle is used to determine the initial course of the ship using the 1, 2, 3 method, exactly as we did in great circle sailing questions. So once we have the longitude of vertex 1, we also have the longitude of our destination position. We can find out the d long between Bravo and Victor 1, and using parallel sailing, we can also obtain the rumb line distance, that is Victor 1 to Bravo. And once we obtain this rumb line distance, AV1 Alpha Victor 1, the GC distance, and Victor 1 Bravo, the rumb line distance, combined together give us the total composite distance.
So can you explain again the second triangle, sir? How we get rumb line distance?
Beta, rumb line distance is easy. Once you get the longitude of vertex 1, the longitude of Bravo is already known to you. So you get the d long between them, and you calculate it using the parallel sailing formula. Departure is equal to d long into cos of m lat.
Okay, sir. Okay, sir. Angle P we can subtract and get the V1P angle. Okay, sir.
Yes, that's right.
Okay.
Now the problem arises. This question can be made little tricky and complicated in case we obtain the longitude of vertex 1 and we find out that the longitude of vertex 1 falls outside the triangle PAB. Once you have a look at the longitude of A, the longitude of P, and the longitude of vertex 1, you will immediately come to know. Say, to give you an example, if the longitude of A is 30 degrees east, the longitude of B is 70 degrees east, and the longitude of the vertex 1 from the Napier's rule comes out to be 80 degrees east. Now 80 degrees east has to be east of Bravo, indicating to us that this Victor 1 is going to be eastwards of Bravo or outside the triangle PAB. If such a thing happens and the vertex comes outside this triangle, it simply tells us that in these type of questions, composite sailing is not required at all. Since the vertex is being achieved outside the triangle, it simply tells us that even if we follow a great circle track from Alpha to Bravo, at no point of time that great circle track will be crossing the limiting latitude. It will always be below the limiting latitude. Since the vertex lies outside the triangle, it tells us that the highest latitude will be attained after crossing our destination position or final position. So in such questions where the vertex comes outside the triangle, we can simply write a remark. As the vertex comes outside, it indicates composite sailing is not required in these questions. And after writing this remark, we can switch over to the GC sailing. We can make a simple GC sailing diagram PAB showing the PAB triangle and solve this using the cosine formula. So if the vertex comes outside, it indicates composite sailing is not applicable, and then we switch over to great circle sailing for getting out the distance between Alpha and Bravo.
Sir, in this case, if
Sir,
they
if-
ask us to find out the final course,
Okay, if this is a normal question, not the complicated one, then the final course is going to be 090 beta. You don't need to calculate it. It is understood if the vertex is inside and composite sailing is happening, the final course will be 090.
okay, sir.
Sir, if the
And
V1 comes outside the triangle, but at the initial position के बाहर, मतलब A के दूसरी side, मतलब A angle is more than 90 degree.
Okay, vertex will never go on the side of A beta. Vertex will always go on the side where higher latitude is there. So out of A and B, higher latitude is Bravo. Okay.
Right, sir, right.
So same we had this in question 4 and question 6. Both are same type of problems.
Exactly,
Yeah,
that's
sir.
right, beta. That's right. So you will find this remark mentioned there in the solution also. If the vertex lies outside, switch over to GC sailing and find the GC distance. Okay, beta, great. So is that clear, beta?
Yes, sir.
Yes, sir.
Very good, beta. Excellent. So I'm closing this down now. Okay, all right. So beta, the IT department tells me that two of the IDs are connected with multiple devices. So please connect with single device. Okay. Please connect with single device. Okay, all right. Now, beta, after this, let's take a short break. We will take a 5 minutes break. And after the break, I will take you to other sailings. We will see the plain sailing and the Mercator sailing. Okay, because in some of the questions they tell you to compare the GC distance or composite distance with rhumb distance. So for calculating the rhumb distance, you need to do Mercator sailing. So we will refresh the remaining sailings also. 2 sailings we have covered. In fact, 3 we have covered: Great Circle, Composite, and Parallel. And we will now cover the remaining 2 also: plain sailing and Mercator sailing. So let's be back after 5 minutes.
Okay, sir.